Hello and a warm welcome to your digital multimeter basics training. We're thrilled to have you join us for this immersive learning journey. Over the course of 6 engaging modules, you'll gain hands-on experience and in-depth understanding of digital multimeter usage and applications. Each module is designed to build your skills progressively, ensuring a comprehensive grasp of the essentials. So, let's get started and unlock the world of electrical measurements together. Technical professionals often use a variety of tools for measuring. One common tool is a digital multimeter. A multimeter is made to measure different electrical values. It always measures voltage and resistance, and usually current too. These are the main measurements, but some multimeters can do even more. Let's grab the multimeter from the bench and take a closer look. On its front, you will see input jacks where you connect test leads and various accessories. A function selector switch to configure the multimeter for a certain type of measurement. A set of push buttons. These buttons are used in conjunction with rotary switch to select operating modes and set power on options. And a digital display that shows the present reading for the rotary switch function. The multimeter uses test leads for measurements. These leads are plugged into the input jacks often found at the multimeter's bottom. The black lead goes to the COM port for common. The connection of the red test lead depends on the type of measurement you are taking. The inputs are labeled with the symbols of their measurement types. Typically, all measurement functions, except for current, are collected at one input. Current measurements might use 1 or 2 jacks. If there are 2, each can handle a different maximum current. It's important to note the labels near the input jacks, as they indicate the maximum allowable current this multimeter can safely measure. The CAT and voltage ratings are also marked near these jacks. Our example here is a dual-rated multimeter with CAT 3 1000 volts and CAT 4 600 volts ratings. Now let's explore how to configure it for a certain type of measurement. This is done with the function selector switch in the middle. The symbols around the switch show different measurement options. Most symbols represent the unit abbreviation of what is being measured. For instance, V is for volts. Some multimeters might also have MV for millivolts, used with electronics, or for some multimeter accessories. A is for amperes, a unit for current. The MA for milliamperes and UA for microamperes are also included in this multimeter. The graphic symbols above the volt or amp symbols identify if the function is direct or alternating current or voltage. The parallel straight and interrupted lines represent current that travels only in one direction. Direct current. For alternating current, a curved line is used to represent the simple sine wave. The symbol for ohms, the Greek letter omega, shows resistance. This position also includes a symbol for continuity, looking like sound waves, because the multimeter emits a beep sound when continuity is found. Symbols for capacitance and diode tests are also there, following international standards. Some symbols on this multimeter are in a different color to differentiate between the primary and the secondary functions. The primary function is the default because it's deemed more common and it's shown in white. The secondary functions are shown in a contrasting color and are reached by pressing a secondary function button, usually in the same color. Pressing the button again goes back to the main function. Along with this button, there are others for advanced multimeter features. We'll discuss these in later lessons. To learn more about the digital display, let's put this multimeter to the test. And as in real life, your every measurement should start with proving your multimeter. So let's bring a proving unit to the table. Put the multimeter on a table. The meter's case features a handy tilt bail for it to perfectly sit on the bench during the measurement. To take a reading, first, ensure your multimeter is set to the correct function and test leads are connected to the correct jacks. Rotate the dial to the AC voltage measurement function. Now connect the test leads by pushing them into the multimeter's input jacks at the bottom. The black test lead goes into the common input, and a red test lead goes into the input labeled with the volt symbol. Now take the test probes and connect them to the test points on a proving unit. Observe the reading from the display. The digital display shows the reading of the measurement being made and consists of both the numerical value and the symbol identifying the function selected. In our case, the proving unit generates alternating current voltage. The selector switch is set to V with the curved line symbol and the display shows 240 volts AC. The multimeter may add prefixes or decimal points as needed in order to display the measurement within the number of digits available. Some multimeters include a bar graph as part of the display. This line of LCD element shows a measurement graphically in relation to the digital numerical reading. The decimal point on the display can be shown in many different positions. Together with the prefixes, this allows the multimeter to display either very large or very small values. When you read the measurement, be sure to include the prefix and pay attention to the position of the decimal point. And this concludes our brief introduction to digital multimeters. Now, let's consolidate your understanding. This quiz will challenge your knowledge of the multimeter's features, functions, symbols, and safety guidelines. What is the primary function of a digital multimeter? Which port should the black test lead always be connected to? If you want to measure resistance, which symbol should the dial be set to? What does the bar graph at the bottom of the multimeter's display represent? Which of the following is not a safety guideline when using the multimeter? When measuring an unknown current, to which port should the red test lead be connected? Which of the following can the multimeter not measure? Congratulations on completing Lesson 1, where you've gained a fundamental understanding of multimeters. You're now equipped with the basics and ready to dive deeper into the world of electrical measurements. Keep up the great work, and we look forward to your continued learning in the upcoming lessons.